Hi, I'm JD, and what we're going to be doing today is a factoring problem. And we're going to try a method that, well, I don't know if I came up with it or not. I don't know if it's out there, but I came up with it. It's kind of similar to the box method. So if you would, please pause the video and see if you can try to do this one on your own. Alright, there's some issues with this one. That's why I'm suggesting a method I came up with. When you take A and C, you get a very huge number. Now the issue with that is because you gotta list out all the factors of whatever 36 times 24 is, but you can't. It's hard. It's not impossible, it's just hard because there's a lot. Now another issue is when you do trial and error, there's going to be a lot of what you're trying and what you're not trying. So, and sometimes students have issues with both. So let me show you my method, and it's based upon foiling. When you FOIL, the first is 36x squared. The middle term is your outer plus your inner. And then the last here is, well, from your last, and that's when you do all the distributing and the foiling and all that good stuff. Now, my method entails setting up a chart or a grid. It's actually more like a grid. So you start by listing out the factors. You have 36, so factors of that would be 1 times 36, comma 2 times 18, 3 times 12, 4 times 9, and then you have 6 times 6. Then you list out the factors for 24, and the factors for 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. You see the issue with this? You have so many factors to deal with. And then when you multiply them, you're going to have even more factors to deal with. So that's why the AC method is kind of not good here. And also the trial and error, because you have so much to work with. So much. But the grid enables you 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's going to be my first. Now I'm going to put a little diagonal here. The top will be my first, and the side right here is going to be my last. And you can either use a dotted line or a different color. It doesn't really matter. And then you start listing out the factors. You just want to make a distinction between the larger blocks and the smaller blocks. So you can use different colors, you can use whatever you want. Here I'm using a dotted line. So I have 1, 24. I'm not really concerned about the variables because I know how the variables are going to end up in the end. 8, 4, and 6. 136, 2, 18, 3, 12, 4, 9, 6 times 6. Now, each grid, each small grid, is a possibility. Now, it's very exhaustive. It shows you every single possibility. So for the first block, what you do to find this smaller one is just simply multiply this by this. So you get 1. This would be 1 times 36. This would be 36, which would be huge. And 1 times 24. If it's huge, you can kind of ignore it. This is a minus sign, so you're either looking for a difference. If it was a sum, if it was a plus sign, you'd be looking for a sum. Since it's minus, you'll be looking for a difference, and it's the difference of the diagonals that you're going to be looking for. So then you just fill out the chart. And again, you're going to get numbers that are huge and then numbers that are not. You have 2 times 24, which is 48. This is something huge because what you're doing is you're going to be taking the diagonals, and the diagonals, the difference has to be 5. So you can start crossing things out. You know, here you have 24 times 3, that's a 72. Huge. 24 times 9, that is huge when compared to 4. Here it's 4 times 96. Right? This is huge. And this is going to be the same thing, which is huge. So you can kind of do process of elimination. You don't have to calculate every single block. Now, I want them to be relatively close together. So I'm going to try, because we can't be here forever. So I'm going to try these guys. So here would be 9, and then 3 times 12 is 36. Then you have 8 times 12 is 72. And then 8 times, you get 24. Okay. What about this guy? 3 times 6. And I have 3 times 18. What's 3 times 18? Yeah, it's 54. 8 times 18, that's going to be huge. 8 times 2 is 16, so that's not going to work. Maybe this. 4, no, 36 is huge. What if they're closer together, like this guy? 16, and then 9 times 4, which is 36. 9 times 4 is 24. 9 times 6, 4 times 6 is 24. 9 times 6 is 54. Okay, that's not going to work. What about 4, 6? 4, 6, and this guy right here. So this is 8. And then 18 times 4 is 72. And then you have 6 times 2, which is 12. And then you have 8 times 6. 8 times 18, sorry. 8 times 18, that's going to be something huge. So maybe I need something that will bring huge numbers closer together. So maybe if I have like a 3 and an 8 and a 4 and a 9, let's see if that works. So I have 12, 27, right? 3 times 9. Then I have 8 and 32, and then 8 times 9, which is 72. And if you notice, that actually works. This is 32 and 27. So this works with this guy right here. Alright, so you have 3 and 8, and this is going to be your middle term, right? because it's the difference between two. So it's going to be your inner and the outer. So this, let's make this the outer, and let's make the 32 the inner, right? Now if I look lines up, this is the first and the first. So I'm going to grab an eraser real quick. I'm going to erase all of these. I'll show you how to set this up. Now, if you go through this, it's going to be unique. It's not going to be the same. But notice you don't have to do all of them, just until you get the difference that you're looking for. So this is your outer, which is 27. 27 is your first. So that's your first. Your first is found by this. Remember, this is outer, right? So your outer is made up of this and that. You see that? Now, the inner has an 8 and a 4. The 8 is the first, which is that, right? 9 times 4 is 36. And then the 8 is the inner, and the inner is on the inside. So you have 8 right there. Now the rest of the variables is piece of cake. This is y and y, right? Because that gives you a y squared. This is going to be an x and an x. Now, I want this 32, the inside, to be negative, right? Because if I have negative 32 plus 25, that's going to give me the negative 5. So the negative has to be on the inner. And the only way that's going to happen, because the first is always positive, is if it's here. So that's it.